I'd like to introduce you to our topic for today, the future of technology in the rail industry. I confess, I am a huge science fiction nerd. Put big glasses on me, put a wacky t-shirt, and I am all for it. I'm always intrigued in what people think the future may be like. Will we enjoy technology like the Jetsons predicted it, with flying cars and helpful robots for everyone's use? Or will we be in awe of it, like Philip J. Fry in Futurama, when he's staring upwards at the tube transport system and all the spaceships in New York? How close are we to making this scene from The Fifth Element a reality? Hover cars, drive-through McDonald's, miles high of skyscrapers. Perhaps more realistically, and with a greater chance of happening sooner than we think, transportation will change drastically with concepts such as Hyperloop. The real question is, where are we today, and what can we see on the horizon? Right now, we are bombarded with technology-focused buzzwords every day. We hear these words, but we may not always know exactly what they mean or how they may impact us. Here's the part where I ask for your participation as audience members to use the chat window. What are some of the tech-focused buzzwords you can think of? We'll read through these as they pop up in the chat. Artificial intelligence is a great one. Everybody thinks of robots and moving forward in the future with that. Big data is a good point. Blockchain, hyperledger. Dare we say Bitcoin in that same sentence? Any other ideas? Some big things that are out there? Yes, predictive analytics. Thank you for the participation in that. We use all these concepts and we don't know what they mean all the time, but how do they impact us today? Pair these words with the hot topics of technology and put them with rail, and you get key concepts that you see here in this word cloud: data modeling, remote sensing, advanced analytics, machine learning, augmented reality. We've all heard these terms, but we may not be able to describe what that looks like to somebody else. We can say we've heard the term, and we can maybe give an example or two, but understanding how we can use it in our day-to-day lives, particularly as we go to work in the rail industry, is a different story. This presentation will dive into the historical impact of technology advancements throughout the ages, how technology is being used today within the rail industry, and explore what the future may hold. No good story starts without a flashback. Let's flash back through history to look at three major industrial revolutions based on the invention and application of key ideas. According to Klaus Schwab, founder and executive chairman of the World Economic Forum, a revolution can be described as the appearance of new technologies and novel ways of perceiving the world that trigger a profound change in economic and social structures. That's a great definition if you're reading it from a book, but what does that mean if you're having a conversation about this topic? Let's look at it from the perspective of the three industrial revolutions to date. Industrial Revolution number one was the steam age, and it shifted culture from being largely agrarian to much more urbanized and industrial. This introduced the concepts of mechanization, steam power, the weaving loom. Those types of machines really came into play. The age of science and mass production brought us the means to produce goods faster and to do more. With mass production, assembly lines, electrical energy, this shift brought about the modern world. Lastly, the implementation and proliferation of digital technology has brought us to today, 2020. Using automation, computers, and electronics, kids these days don't understand what a rotary phone was. We are in the age of technology. What does this path through history look like in rail specifically? The application of digital technology in rail is becoming more prevalent day after day. Concepts such as property lines and track alignment were historically captured manually on paper and distributed in hard copy. Here we have a few examples of valuation maps and track alignment drawings. These concepts have since been digitized and are now being accessed, maintained, distributed, analyzed, and synthesized via various technology touchpoints such as web and mobile applications. Why pursue the application of digital technology? What's the goal? There are numerous benefits to these advances, such as increased productivity, increased safety, enhanced security, better plans, and working smarter. What impact does that have on rail? The ability to implement digital technology and its advancements is changing the way work is done in all facets of the railroad business. Increased collaboration is one of the most noticeable impacts. This collaboration exists between teams, departments, railroads, vendors, and even the public. Let's take a deeper look into some examples of these concepts benefiting from the use of technology. The American Association of Railroads highlights key aspects of how technology is enhancing rail safety and efficiency overall. Some of these technologies include advanced fuel management systems, positive train control or PTC, modern Tier 4 locomotives, smart sensors, and automated inspection equipment, just to name a few. Railroad crossings are one of the most dangerous places for a vehicle or pedestrian to be stuck at. According to Operation Lifesaver, it's still a startling fact that every day, about every 3 hours in the US, a person or vehicle is hit by a train. There have been over 2,000 vehicle-to-train collisions every year since 2012 in the United States. Although this number is lower than it has been when looking back to, say, the 1980s, it has nearly plateaued at 2,000 per year for over a decade. Will Miller of Norfolk Southern presented at the ARDA Executive Forum in February 2020 about initiatives underway to improve grade crossing safety for both the public and the railroad themselves by partnering with social mapping applications such as Waze. The goal of that project was to create a method to notify motorists when they are nearing a railroad crossing through a safety pop-up window within the Waze application. To make this happen, data sources and safety message content was supplied by Norfolk Southern to Waze for integration within the application. A pilot project was rolled out to select cities that are greatly impacted by Norfolk Southern's rail network. The pilot project was deemed such a success, and efforts are now underway to roll out the solution to all geographic areas along the rail network with support from Waze. In September 2018, the large and slow-moving Category 1 Hurricane Florence produced record-breaking rainfall across eastern North Carolina and a portion of northeastern South Carolina. Record river flooding developed after the storm passed, destroying roads, homes, and numerous forms of infrastructure, including the rail corridor. So how does technology play into this when we need to focus on increasing safety when natural disasters occur? Railroads need to understand where it's safe or not safe for crews to go, where washouts exist, where trees may have fallen onto track. CSX, which is a leading supplier of rail-based freight transportation in North America, has been on the forefront of the application of digital technology in the rail industry. According to an article recently written by Esri, Eric Henderson and his team at CSX have created an app that uses real-time awareness from drones, GIS, and the Internet of Things to help CSX immediately assess storm damage and speed recovery while protecting workers. The impact of this application was immense in the recovery of CSX rail network in the aftermath of Hurricane Florence, and has since laid the groundwork for preparing for natural disasters in the future. Smart applications are becoming commonplace. What are some of the smart technologies you use today? How many of you have a Nest or Ring doorbell that you access through your cell phone to answer the door when you're not at home? How about smart switches in your house? So when you walk into the door, your whole home's connected, your living room turns on, your kitchen turns on, and the bedroom lights stay off. Can you close the garage door from the store parking lot if you forgot? That same concept of having all your assets connected creates this idea of the Internet of Things. This concept is making its way into every facet of life, beyond just the doorbell, from how to receive data to conduct business and interacting with others to transporting goods. Within transportation, this Internet of Things or IoT can solve almost any issue where it's involved. Think of the potential increases in safety in vehicular traffic if cars could connect wirelessly with local traffic lights and provide a warning to the driver that the light's about to turn yellow or red. Some cars already have the capability to self-monitor when driving outside designated lanes or highways using sensors. Pair all of that information with driving patterns through intersections, and you've now increased your safety and efficiency of design in developing traffic patterns. But when you look at the Internet of Things, how do you tie it to the railroad? Not everybody gets on the rail, whether it's transit or freight. Most people get really annoyed at railroads blocking their driving paths. So how can IoT tie into this, making things safer and more efficient? According to Business Insider, Rio Grande Pacific is leveraging the Railway Internet of Things to collect and analyze large amounts of data quickly. The variety of connected devices that comprise the Railway Internet of Things along the rail corridor allows for data collection, data storage, and data transfer to a secure data solution that encourages further analysis and decision making. Increasing safety by track inspection and maintenance efforts, increases to on-time performance, and overall cost savings are just a few of the benefits that Rio Grande is seeing from their ability to embrace and implement the emerging technological concept of the Internet of Things. Another idea of focusing to work smarter with technology within rail is the ability to bring together multiple parties on a project. But having all the necessary data to effectively collaborate on an effort is a whole different topic. Omnitrax, which is a transportation and infrastructure holding company based out of Denver, Colorado, has a goal to make shipping by rail as easy as shipping by truck. This can be done in part by leveraging a multitude of digital data sources into a collaborative platform for shippers, customers, and Omnitrax personnel to facilitate this idea of rail made easy. They boast flexibility, reliability, and cost savings as benefits of the Omnitrax company. The Rail Made Easy solution highlights the use of technology for solving larger, more complex problems within their network. Another concept of working smarter with technology is highlighted here with BNSF's use of track geometry cars to identify anomalies in tracks. The goal here is to respond quickly to any issues, keeping small problems from becoming big ones. Using geometry cars keeps personnel off the track and increases safety. Data collected is being paired with machine learning to predict potential track problems before they occur. According to an article in Railway Age, BNSF commented that geometry cars allow them to precisely measure the health of the track while under load and at train speed. By adding geometry car inspections, they can enhance inspection efforts on areas where there may be condition-based concerns as a result of heavy loads while also performing federally mandated calendar-based inspections. On the other hand, you get concepts such as locomotive simulators. CSX is leveraging these for training their engineers on safe operations through scenarios in a virtual setting. The images you see here are from CSX Moves. It's a software simulation that helps explain the activities necessary to provide accurate and timely service to customers across the CSX system in both the US and Canada. This is an educational tool. It was developed by a cross-functional team as part of a year-long project to help their customers understand how they can serve them better. Wouldn't it be great if we could understand why a shipment is late or what complexity goes on behind the scenes? Although the CSX Move simulator is fictional and for use by the public, the simulations used internally at CSX are based on real-world information collected with advanced imaging technology. True curves, elevation, and spatial awareness of buildings and overpasses are accurately represented in the internal simulator along the track, thus providing a realistic scenario rather than the video game mock-up that you see here. Machine vision is one of those big buzzwords that we hear, and Union Pacific has been putting machine vision to work. Manual inspections are becoming a thing of the past as machine vision is being deployed along the UP network to collect and process thousands of images for analysis to identify anomalies of locomotives, trains, and their components. Union Pacific was previously required to manually inspect the locomotives as they entered or left a rail yard, but have recently turned to an autonomous machine vision system. As a result, the engineers have sped up the process by using imaging areas such as the one seen here, which are able to create 3D models of the train carriages while they travel at high speeds. Technology here is being used to drive both safety and efficiency. There are so many other technology implementations that we can talk about, but I wanted to hit a few key highlights around the whole US rail network. Some railroads, such as Canadian National, are using sonar to address the stability of bridge piers for increases in erosion and other anomalies. Pair this with technology in situations where the waters are murky due to either big storms or flooding events, and bridge engineers now have a better sense of what's going on underwater without venturing into unsafe conditions for traditional divers and bridge assessors. Canadian Pacific is implementing acoustic bearing detectors as a type of smart sensor to predict when bearings will overheat. They're pairing this information with data from hotbox detectors for a full solution, and the results have been a near 3-month lead time on predicting asset maintenance and potential failure. The approach reaps benefits in terms of increased safety and rail network efficiency by protecting the infrastructure as a whole. And here's our favorite term, big data. No complex words here, but lots of information. Big data is playing a key in advanced analytic efforts at Norfolk Southern, especially when it comes to predicting rail wear and tear over time. Models and algorithms backed by machine learning and artificial intelligence are leading predictions that aid in proactive track repairs and maintenance, rather than responding to incidents after they occur. What other technology solutions could be implemented in the rail industry specifically? Blockchain is a great example of one of these solutions. Blockchain, in a nutshell, is nothing more than a decentralized, secure database that serves as a storehouse to validate events that happened in the past. In layman's terms, it's a digital encyclopedia that people have validated the information. The main features of blockchain are fivefold. No one has a single entity to control the flow of information to the blockchain itself. Different parties maintain exact copies of the same ledger, so everyone has to agree on the information being added to the blockchain. It's an add-only concept, so you cannot change a previous entry. New information cannot conflict with what's already recorded, and anyone in the network can access and replicate the information stored. In the medical industry, blockchain is being used to solve the problem of the lack of transparency between medical institutions in terms of sharing data safely and efficiently. I don't know about you, but I don't need my medical history floating around in paper space and getting lost or into the wrong hands. But I also want the medical industry to have access to my information in case there is an emergency and I'm across the entire state. It needs to be accessible, transferable, yet secure. So how can blockchain step in and manage that information for us? Those 5 key components we just discussed really drive the technological capability of having secure data. How could blockchain be used in Rail? That's what we're here to talk about today. Legal documents transferring ownership of property is just one area that's being explored within the rail industry for the use of blockchain. It's all behind the scenes and it's intangible information. What about tangible technology solutions? What about wearables and augmented reality? I'm not talking about costumes, although they are fun. I'm talking about wearables or devices that deliver more data to you, right at your fingertips, or even as an overlay within your vision. Think of Google Glasses, Oculus, and a variety of mobile devices that bring the benefit of supplemental data to your real-world scenario. This technology is already in play in numerous other industries, particularly for manufacturing and repair, and it's making its way into the rail industry in both field and repair shop uses. What other concepts does the future hold? How about voice-activated documentation? Let's put Siri and Alexa and Google to work, notating observations that are seen in the field, rather than writing them down on a piece of paper, ending up in the roadmaster's truck, and eventually making it back to the field office, perhaps getting back to headquarters for processing. Think of the lag time in that scenario. Think of the efficiency that can be gained when using a voice technology to notate that observation and receiving the information all the way back to headquarters within a matter of minutes. Not surprisingly, some of these concepts are already under development and they're rapidly being implemented. According to Klaus Schwab again, we're embarking in what's called the 4th industrial revolution. It's characterized by a range of technologies that are fusing the physical, digital, and biological world. It impacts all disciplines, economies, and industries, and even challenges ideas about what it means to be human. Hold on, we're not talking robots and stuff here. That doesn't make any sense. But what it does mean is we are all becoming more connected. This new revolution is fundamentally changing the way we live, work, and relate to one another by incorporating everything we've learned through the previous 3 revolutions, focusing on cyber physical systems, the Internet of Things, and networks. We are now in this 4th industrial revolution. The real question lies in what impact does this have on rail and the industry as a whole? We should be exploring the capabilities of each new technology as it develops and testing methods of implementation and integration with existing solutions for the purposes of adopting a better way of doing business and delivering services. This does not imply that all field operations will be performed like robots, all named Johnny Five. Nor does it mean that locomotives are to be operated by remote engineers in an operations center or even automatically. What this does mean is that as technology advances in its accessibility, ability to operate in various integrations, and overall capabilities to increase, we are on the edge of a future where each new day is monumental in how services are rendered and goods and data are moved across our physical and digital networks. So what are some of the key takeaways for today? It may not be that the creation of new technology, but the approach and application of that technology as a solution to the problem in front of you. It may be that the challenges we face today require the integration of existing data sources rather than a new tool or widget to process information. There are no limits on the inquiries that can be made once these two concepts are combined. With integrated data across multiple sources that may not be native to your industry, combined with unique approaches and/or the application of these solutions, there is no challenge too large or too complex if we continue to work at it.